Alright, let's look at the third type of partial fractions where the denominator has repeated roots. So I'll look at this example here. As you can see, we have x plus 1 divided by x plus 3 squared. So x plus 3 is actually a repeated root because it's a repeated factor, x plus 3 into x plus 3. So let's go ahead and work on this. So we have x plus 1 divided by x plus 3 squared. And what happens here is that we will write this as a divided by x plus 3 plus b divided by x plus 3 squared. So what happens here is that we keep on increasing the power. This is to power 1, this is to power 2, because that's the final power here. So we stop here. If we had more than 2, then we would simply go on increasing the power until we reach the highest. Alright, so there we go. Here we have x plus 1 divided by x plus 3 squared is equivalent to, now of course the LCM of these two is simply x plus 3 squared. If I divide that here, I'll have a into x plus 3 and then have only b here. Of course this can cancel with this, so I have x plus 1 is equivalent to a into x plus 3 plus b. So let's put some nice value of x here. Right, so I'll put, if I put x equals, what value of x would you choose here? Let's choose negative 3. That's a nice one for this example. So if I put x as negative 3, we'll have negative 2 equals 0 plus b. So there we have the value of b as negative 2. Let's put another value of x. Alright, let's put, what value of x would you put now? Let's choose any value of our choice. Maybe let's choose 1. If I put 1 here, that will be a 2. If I put 1 here, that will be 4a plus b. And I know the value of b already, so 2 equals 4a minus 2. If I bring this here, it becomes 4 equals 4a, so a equals 1. Now I have the value of a and I have the value of b, so I can now rewrite this partial fraction as, remember from here, I actually have a divided by x plus 3, so that's 1 divided by x plus 3 plus b, which happens to be a negative, so I'll have minus 2 divided by x plus 3 squared. Alright, that's a nice one. So this is our final solution. There we go. This is our partial fraction to represent this. Let's go ahead and do one more example here. So I'll take another example. Let's take this example 2, and in this example I'm going to have 1 divided by x plus 2 and then x minus 1 squared. Alright, so 1 divided by x plus 2, x minus 1 squared. As you can see, this is a linear factor, and this is a linear factor, but it's actually repeated because it's a square, it's squared here. So what I'm going to do with this is to start by letting this to, saying a divided by x plus 2, alright? And then for the repeated factor here, I'll now begin b divided by x minus 1, that's to the first power, and then c divided by x minus 1, and that's the second power. So we're done. Alright, so I have 1 divided by x plus 2, x minus 1 squared, equivalent to, oops, so bad at drawing lines. Okay, so the LCM here, x plus 2, x minus 1 squared. So if I divide this by x plus 2, I have x minus 1 squared plus, okay, if we do that for b, so I'll have b into x plus 2, x minus 1, oops, okay, plus c into x plus 2. Alright, so this cancels with this. Now we have 1 being equivalent to a into x minus 1 squared plus b into x plus 2 x minus 1 plus c into x plus 2. Let's choose some nice value of x. So I'm going to choose, I put x equals 1, that makes this and this 0. So that gives me 1 equals, this is 0 plus, what's that? 3c. Okay, so c is 1/3. Okay, it's a nice one. Let's choose another value. Right, so I'll now put, what other value of x is interesting? Perhaps -2. So if I put here -2, I'll have 1 equals, that's -2 minus 1, that's -3 squared, which is actually 9. So I have 9a. The rest of it is going to be 0. So 1 equals 9a, and a is actually 1/9. 1 divided by 9, right? One more value to go. So let's put, what other value of x? Okay, is there any value of x that will make one of the coefficients 0? I don't think so. So I'll just choose my own value of x, says 0, just any value that is convenient. So that gives me 1 equals, right, so if I put here is 0, 0 minus 1, that's -1 squared, which is 1. So I'll just have a there, plus, if I put 0 here, that's a 2. 2 times -1, that's -2b. Alright, if I put here 0, that's 2c. Let's plug in the value of a and the value of c. So we'll have 1 equals 1 divided by 9 minus 2b plus 2 times c, right? So that's 2/3. Okay, so we can do the math now, and you'll actually find that the value of b, right, so the value of b here is going to be 1/9. All right, so just shift values around, you'll actually find the value of b to be that one. And now I can rewrite my fraction here in form of partial fractions. Let's go ahead and do that. So I have a over x plus 2. So a, just to show you what this is, I have it up here. All right, so a, which is actually 1/9. So I'll write that as 1/9 into x plus 2, okay, plus b, which is 1/9 also, okay, into x minus 1, plus c, which is 1/3 into x minus 1 squared. So this is our partial fraction for this. Right.